Hello everyone. This tutorial will be about a complete example on half-wave rectifier circuit. After understanding half-wave rectifier circuit and the operation of this circuit for producing high voltage DC, and also how to calculate the DC output voltage and also how to calculate the ripple voltage, now let's make use of this valuable information to take this example on half-wave rectifier. So what is this example? It's required to produce high voltage DC in high voltage lab using half wave rectifier circuit as shown. This is our half wave rectifier circuit. To produce this high voltage DC using half wave rectifier circuit, we use high voltage transformer as the first step of our circuit. This high voltage transformer has a voltage ratio 250 to 250 kilovolt. This is the primary voltage and this is the secondary voltage of high voltage transformer. And the test object has a load resistance 5000 kilo ohm. The test object here is our insulator, which is RL here. And we can see that the insulator or the test object has a very high resistance, 5000 kilovolt, 5000 kilo ohm, because the insulator is already a high resistance. You can understand that the perfect insulator has an infinite resistance. And the supply frequency is 50 Hz. Also, the ripple voltage, which is delta V, should be limited to 12 kilovolt. In our half-wave rectifier circuit, we should limit and restrict the ripple voltage, which is called delta V, to 12 kilovolt. How we can do that? You should understand that the smoothing capacitor can control and limit the ripple voltage. We will see in this example how we can design the smoothing capacitor to limit this ripple voltage. So this is our givens in this problem. What is required now? First, estimate the size of a suitable smoothing capacitor to limit the ripple voltage to 12 kilovolt. We need to find the value of the smoothing capacitor here, or find the value of this capacitor to limit the ripple voltage to 12 kilovolt. We will see how we can do that. Also, after that, find the value of the DC output voltage. Here, the output voltage DC, which is high voltage DC, of course. We want to find this DC voltage of the half-wave rectifier circuit to know how can this circuit produce high voltage DC. Find the nominal load current, which is the current that flows in the insulator. We can predict that this current will be very, very small in range of milliampere because perfect insulator almost has no current in it, no current passing through it. But we deal with practical insulator, so the current will be very, very small in range of milliampere and sometimes in range of microamperes. After that, draw a simplified waveform showing the related voltages of the following circuit. We will draw a simplified waveform to show on it the voltages that we obtained from the circuit. Now let's see the answer. First, we should extract the givens from the problem. The first given is the maximum voltage. The maximum voltage in our circuit is the maximum of the secondary circuit of the high voltage transformer, and the secondary voltage of the high voltage transformer is 250 kilovolt, but we multiply this value by root 2 to obtain the maximum voltage. We know that the relation between the maximum and RMS is root 2. Maximum equals RMS times root 2. So we need to obtain the maximum voltage. We will multiply the RMS voltage of the secondary of the transformer times root 2. So the maximum voltage will be 353.5 kilovolt. Also, the supply frequency is 50 Hz. The load resistance is 5000 kilo ohm. and also the rebel voltage should be limited to 12 kilovolt. These are the givens of the problem. Now let's find the first required. We need to find the smoothing capacitor to limit this rebel voltage to 12 kilovolt. We can use the equation of the rebel voltage that obtained from half-wave rectifier circuit. This equation says that the rebel voltage equals the maximum voltage, which is the maximum of the secondary of the transformer, this maximum voltage over 2F RLC. From this equation, we know that rebel voltage is 12 kilovolt, and the maximum voltage is obtained here, 353.5 kilovolt. We multiply this value by 1000 to obtain it in volts. Also, the supply frequency is 50 Hz and the load resistance is 5000 kilo ohm. From this equation, we can obtain and find the value of the smoothing capacitor to limit the rebel voltage to 12 kilovolt. So the value of the smoothing capacitor will be 58.9 nanofarad. So this is the design of the capacitor to limit this rebel voltage. The value of the capacitor shouldn't be less than this value, because if the capacitor decreases below this value, if the capacitor decreases here, the rebel voltage will increase. So the value of the capacitor shouldn't be less than this value. The second requirement is to obtain the DC voltage. We know from the equation of the DC voltage that VDC equals maximum voltage times 1 negative 1 over 2FRLC. So by substituting with the maximum voltage and the supply frequency and the load resistance and also the capacitor obtained in this equation, we will obtain the DC voltage is 341.5 kilovolt. So this is the DC voltage of the half-wave rectifier circuit. So we can obtain from this value that the half-wave rectifier circuit in this problem can produce high voltage DC up to 341.5 kilovolt. Then we should obtain the nominal output current. We can deduce the equation of the nominal output current. Nominal output current equals maximum voltage over RL. So the maximum voltage here is 353.5 kilovolt over the load resistance or the resistance of the test object, which is 5000 kilo ohm. So the nominal current which flows and passes in the insulator or the test object is 70.7 milliampere, and this value is absolutely predicted. This value is small value in ranges of milliampere because we have insulator and the current that passes in the insulator is very small. Now let's get the final requirement, simplified waveform. So this is our simplified waveform. This is output voltage of the half-wave rectifier circuit. As we see, it's a DC voltage, a DC average voltage with some rebels. As we see, the output voltage has a maximum value which is 353.5 kilovolt. Also, this maximum value is the maximum of the secondary of the high voltage transformer. This value is obtained in our problem, and the DC voltage of this waveform is also 341.5 kilovolt. So we can obtain the minimum voltage for this waveform will be 329.5 kilovolt, and the difference between the maximum and the minimum is 24 kilovolt, which is 2 times of the rebel voltage. So the rebel voltage will be 12 kilovolt. And this is the important parameters of the half-wave rectifier circuit: the maximum voltage, the minimum, and also the rebel voltage, and also the DC output voltage, which is the output of the half-wave rectifier circuit. So this is a complete example of half-wave rectifier circuit and how we can design the value of the smoothing capacitor to limit the ripple voltage, how to calculate the DC output voltage, how to obtain the maximum and minimum voltage of the output voltage of the half wave rectifier circuit. Thank you and see you in the next lectures.